An introduction to functions, a fundamental concept in programming. Functions in C help us divide a large and complicated problem into smaller, easy-to-handle parts. Instead of writing one long block of code, we can split the program into separate functions, each handling a specific task. This makes the program easier to understand, test, and reuse. So, functions basically help us organize our code and reduce complexity. Recursion is a technique where a function calls itself to solve a problem step by step. Let's talk about a very interesting concept in programming, recursion. Recursion simply means a function calling itself. Yes, a function that calls itself again and again, but in a smart way. To write a recursive function, there are two important rules to follow. First, there is a statement in the function body which makes a call to the same function. Second, and most importantly, there should be a terminating condition or a base condition so that the function stops calling itself at some point of time. A classic example to understand recursion is the factorial of a number. The factorial of n is calculated as n factorial equals n times n minus 1 factorial. This means the factorial of a number is the number itself multiplied by the factorial of 1 less than that number. For example, let's take 5 factorial. 5 factorial equals 5 times, 4 times, 3 times, 2 times 1. So, the function keeps calling itself with a smaller value each time, until it finally reaches the base case, usually when n equals 1. Let's trace the problem of finding the factorial of 5 using recursion. We start with factorial of 5, which can be written as factorial 5 equals 5 times factorial 4. Since factorial 4 is not yet known, the function calls itself again to find it. Next step, factorial 4 equals 4 times factorial 3. This process continues. Factorial 3 equals 3 times factorial 2. Factorial 2 equals 2 times factorial 1. Factorial 1 equals 2 times 1 equals 2. 1 times factorial 0. Here, factorial 0 is our base case, which simply returns 1. Once we reach this base case, the function no longer calls itself. Now the results start returning back up the chain. Factorial 1 returns 1. Factorial 2 becomes 2 times 1 equals 2. Factorial 3 becomes 3 times 2 equals 6. Factorial 4 becomes 4 times 6 equals 24. And finally, factorial 5 becomes 5 times 24 equals 120. This step-by-step breakdown shows how recursion breaks a big problem into smaller parts and then combines the results to get the final answer. Let's see a problem statement. Write a program that finds the factorial of a positive integer using a recursion called factorial, which finds and prints the factorial of a positive integer passed to it. Algorithm. Step 1. We start the program. Step 2. The user is prompted to input a number, which we'll call n. Step 3. Call our recursive function, factorial of n. Step 4. Inside the factorial function, the first thing we do is check if n is equal to 0. If yes, that means we've reached the base case, and the function simply returns 1. If no, which means n is greater than 0, then the function calls itself again with the value n minus 1. At the same time, it multiplies the current value of n with the result of that recursive call. This process continues until n becomes 0. Step 5. The final result is returned to the main program. Step 6. The program then displays the calculated factorial to the user. Step 7. And finally, the program ends. This flowchart shows how factorial is calculated using recursion. We begin with the start point and call the recursive function factorial n. The function first checks if n equals 0. If yes, we've reached the base case, the simplest condition where no further calls are needed. The function immediately returns 1. If no, we move to the recursive step. The function returns and times factorial of n minus 1, calling itself again with a smaller value. This cycle continues until the base case is reached, and then the results flow back up, producing the final factorial value. First, we include the header file, number sign include. This allows us to use input and output functions like printf and scanf. Next, we declare a function named factorial that takes an integer n as input. This function will call itself repeatedly to calculate the factorial of the number. In the main function, we declare two variables, n for the input number and result to store the factorial value. Now we call the function result equals factorial of n. After that, we display the result using printf factorial of n is result. Let's now understand the factorial function. Inside the function, we check if n is equal to 0. If yes, we return 1, because the factorial of 0 is 1. Otherwise, we multiply n with the factorial of n minus 1. This process repeats until the value of n becomes 0. Finally, the program prints the factorial of the entered number. For example, if we enter 3, the program calculates 3 times 2 times 1 equals 6. So the output will be factorial of 3 equals 6. 3 is 6. That's how this simple recursive factorial program works in C. Let's visualize how recursion works step by step for finding the factorial of 3. The main function starts and calls factorial 3. Inside factorial 3, since n is not 0, it makes another call, factorial 2. Now control moves to factorial 2. Again, n is not 0, so it calls factorial 1. Next, we enter factorial 1. Still, n is not 0, so it calls factorial 0. Inside factorial 0, the condition n equals 0 becomes true. So this function doesn't call itself again. It returns 1 to its caller. Now the recursive calls start returning in reverse order. Factorial 1 receives 1 from factorial 0 and calculates 1 times 1 equals 1. It then returns 1. Factorial 2 receives that one from factorial 1 and calculates 1 2 times 1 equals 2. It then returns 2. Factorial 3 receives 3. 2 from factorial 2 and calculates 3 times 2 equals 6. Finally, it returns 6 to the main function. The main function then prints factorial of 3 is 6.